Okay, this is the 25-2, the inscribed angle lesson. This is the check your understanding and the lesson practice answers. So if an inscribed angle in a circle intercepts a semicircle, so I have it right here, there's the inscribed angle, its vertex is on the circle, and it intercepts that semicircle. So that arc, the fuzzy arc that I drew right there, is 180 because it's a semicircle. How much is the angle? Half of 180, sorry, is 90. So it's 90 degrees, and it says so right there. The angle is a right angle. Number 17 says, look at circle O where ABC quadrilateral is it's quadrilateral, is inscribed. That means all the vertices are on the circle. That's what inscribed means. AC is the diameter, so I drew AC in. So that means that you got a semicircle right here and a semicircle right there. That's what I put the 180s on there for. And the measure of angle DAB is 122. So, just based on what I know, find the measure of angle BCD. Okay, well, here's what I do know. I know that this piece of the arc, the piece of the arc that goes from D to C to B. I drew it along the outside right here, but that's may not helpful. So maybe I'll just do it right here. From D to C to B. I know what that arc is. And the reason I know what that arc is because that's the intercepted arc for this angle. You see, that angle intercepts the circle at D. This side of the angle intercepts the circle at B, so all of the stuff between D and B is the arc that goes with it. So starting at D, and that's the letter D right there, all the way around to B, what's the measure of that? An inscribed angle is half of its arc. So 122 is half of the arc. So to find out what the arc is, you have to take that angle and double it. And if we double it, we get 244. So this arc right here is 244. And now you're saying that's not what they asked us. You're right. They did not ask us that. They want the measure of this angle right here where I put a question mark. Well, in order to find that angle, we'll need this arc from B around to D this way. Well, we don't know that. But we do know D to B around this way. Okay, so D to B around this way is 244. D to B around this way is whatever 360 minus 244 is. So take 4 away from 10, you get 6. I borrowed one, that's 5. Is that 116? So the measure of this arc right here is 116. So that circle is in two pieces if you're looking at that piece. From D to B, the long way, and from D to B, the short way. The long way is 244, the short way is 116, and when you put them together, you should have the whole circle. So if the arc is 116, then the inscribed angle is half of that arc. So 116 divided by 2, is it 58? Yeah. So this measure right here is 58. And they tell me it's 58 right there. What are the measures of angle ADC? Well, that's 90. Remember, that was a semicircle, so that's 90. This is a semicircle, so that's 90. So explain your reasoning. It's the intercepted arc of a semicircle, so they're 90 degrees. Janet states that AC is a line of symmetry. Name a property about kites that help Janet support their statement. So remember, kites have at least one pair of congruent opposite angles. So we see that these are congruent. They're both 90. So that's a property of kites. So that should be a line of symmetry then, because these two legs are the same. These two legs are the same. We've got that reflexive line, so that's two congruent triangles. How can you use what you learned in this lesson to prove that the sum of the measures of a quadrilateral inside the circle is 360? Well, because we just made two triangles. This one was 180 and this one was 180, and put them together and it makes 360. Okay, so now let's go down to lesson 25-2. Draw an angle inscribed in a circle such that its intercepted arc is a semicircle. Heavens to Betsy. We got another one of those. So there we go. They drew it for you right over here. Label the measure. Yes, it's 90. Why? The intercepted arc is 180. This diagram is not drawn to scale, so what they're saying is, if this angle looks acute, that doesn't mean that it's really should be obtuse. So don't pay attention to the size. Which angles, if any, are right angles? Well, that's a right angle for the same reason that one was a right angle. AB is a diameter. How do I know? I can see it's going through the center. What is the sum of DAB, so this one, and DCB? Do you see the quadrilateral right here? Quadrilateral. Opposite angles of a quadrilateral equal 360. That's what we just did right there. So if this is 140, then this right here is going to be, take 360, subtract, no, not 360, it's going to be 180. All four of them have to equal 360. So opposite angles are supplementary. So this one's going to be 40. And the reason that one's going to be 40 is because 140 plus 40 equals 180. Opposite angles are supplementary. Okay, so 180 opposite angles inscribed are supplementary. There you go. Identify an angle with the measure of 40. We just did. Angle DAB. It says, name the quadrilateral that when inscribed in the circle has angle pairs in which one angle measures twice the measure of the other one. So they say it's an isosceles trapezoid. That when one angle measures twice the measure of the other one. Yeah, that's not a special thing. Okay, that's it for lesson 25-2.